So, what I'm going to do here, guys, is find the missing coordinates of each of the following parallelograms P, Q, R, S. Now, first of all, a parallelogram. Can anybody tell me any features of a parallelogram? Two sides are the same length, and the other two sides are the same length. What else can you tell me about a parallelogram? Same. They're also the same slopes, aren't they? So two sides have the same slope. And when you're talking about PQRS, what does that mean? It means P is connected to Q, Q is connected to R is connected to S, and S connects back to P, or any variation of that. You couldn't, for as an example, once again my Q does not look like a Q. So this Q here, imagine I changed S and R around. Would this be the same parallelogram? If I changed around R and S? That makes no sense because Q is not connected to R. Has to be connected to R because it says PQRS. P is connected to Q, Q is connected to R is connected to S. Has to be like that. Okay? So let's bring back the way it was. Now on part 2 we just draw out our coordinates and we'll draw them in. -2 minus 1 is P. 2 minus 2 is Q. S is 2, 3. 2 across, 3 up. Now, looking at this diagram, where does R have to be? Can R be up here? No, why not? Perfect. So where is R going to be then? Has to be over here somewhere. And what we're going to do is we're going to measure it from, see P, what Lee was saying, from P to Q is 1 down, 4 across. So from S to R, 1 down, 4 across. And you can see that you've completed your parallelogram. Everybody alright with that? Okay. So what is the coordinates of R then? 6, 2. Okay. That's not too bad, was it? Okay. Part 4. Okay, just had to draw it out again, don't we? Question 4. Oh, 3 was it? 3, sorry, Lee. 3. -6 minus 3. Q we don't know. R. Yeah. S. Okay. And that's S. P, Q, R, S. Q's got to be over here somewhere, doesn't it? So what's... Go for it. One, two, three, four, 6 up, 6 across, and 4 up. Yeah, 6 across, 4 up, which would mean the same thing here. 6 across, 1, 2, 3, 4, 5, 6, 4 up, and that's your point there. And then when you join them together, you can see that you have yourself a perfect parallelogram. What point is that then? 0, 1. Okay. Good. Move on to number 6. Find the image of the point -1, 2 under central symmetry in the point 2, -3. Okie dokie. So we have here is the xy axis, and we have find the image of the point -1, 2, and then central symmetry in the point 2, -3. There we are there. Can anybody tell me what central symmetry actually means? You gotta go through this and out the same distance. That's central symmetry. So we go down 5 across 3, then we go down another 5 across 3. We can see it's a straight line now. And what's out the other side? 5 minus 8. Is that right? Can anybody give me a different way of doing it that doesn't involve a diagram? Go, Cameron. So to go from -1 to 2, you add 3 to x, and to go from 2 to -3, minus 5 to y. So add on 3 onto 2. 3 to the x value gives you 5. And then finally take away 3 from minus 3. Sorry, take away 5 from minus 3 and you get minus 8. Arguably it's quicker, but you might not understand it. Okay? It's just moving it the same. See, adding 3 to x is moving it across 3. Taking 5 away from y is moving it down 5. That's actually without drawing the diagram. That's what that does. Okay? Last one, question 9. Now, with question 9 is the image of A under central symmetry in B. So we have to draw these two lines here. And where is B? B is 4 minus 5. And A is 2 minus 1. Okay, first of all, central symmetry in B. So A getting reflected through B. 4 down, 2 across, 4 down, 2 across. And that leaves us here. That's the image of A. So what is the image of A through B? 1, 2, 3, 4, 5, 6. 6 across and how many down? 6 minus 9. Alright. 6 minus 9. Now, what we have to do next is the opposite way around. So, that was 6 minus 9. What about this one? The image of B under central symmetry in A. So, B goes through A. 2 across, 4 up. 2 across, 4 up. And what do we get? 0, 3. Okie dokes.